Hi, welcome to the Mind Factory. In this channel, we reproduce the latest results in artificial intelligence, deep learning, and robotics. This video is part of a series of videos where we are reproducing a paper called Learning Fine-Grained Bimanual Manipulation with Low-Cost Hardware from researchers at Stanford and Berkeley. In this video, we're going to be configuring all the software required to control the robot. So, if this kind of content is interesting to you, like the video, consider subscribing, and let's get into it. So the next step is to install the software. And so to do that, we start out by going to github.com/aloha. Take a look at the quick start guide. First thing you'll notice is you're going to need a ROS 1 noetic install on either Ubuntu 20.04 or Ubuntu 18.04. I have here a fresh install of Focal 20.04. Then once you have the correct operating system, you're going to want to set up the interbotix software. So interbotix provides an installation script to do that. Just go to the interbotix link, select ROS interface, go to ROS 1, and then the ROS 1 software setup guide. So under the AMD 64 architecture, you'll find these instructions, and you can just install curl, grab the download script, make it executable, and then execute it. Okay, and that is going to install the software. Install the perception packages. No. Install MATLAB. No. I'm not going to use MATLAB. Yes. All right, and now just let that run. It's going to install ROS first, and then it's going to put their software on top. Okay, so the installation is complete, and now we're just going to reboot. All right, so now we're just going to do the verification steps and just run through these. That's there. Let's source the ROS setup, source the interbotix setup, and then check our packages. And that looks like they've all installed, so we're good to go. Okay, so one more quick tip on checking that everything's connected. If you do an LS USB, you'll see your Logitech webcams connected, and there should be 4 of those. And this guy, these are actually the robot arms. Okay, these Future Technology Devices International. And the way I know that is if I go into etc udev rules, during that install, there's a new rules file, and you can see here that the U2D2 board has a vendor ID of 0403, okay? And you'll notice that this Future Technology Devices International has 0403, and then we've got 614. So this matches the expected vendor and product ID. Okay, now we'll just go back to Tony's GitHub here, and we can see that the next step is to install the USB cam and CV bridge packages. So we'll just do that right here. And then he wants us to run a cat and make. So now he wants us to make this configuration change on the ARM PI file. So just pull that up. And we're searching for publish positions. Okay. So And he wants us to change that to this. Okay. Right, okay, because we don't want forward kinematics at every step. Great. Okay, so the next job is we want to get the Dynamixel wizard. Let's go grab that. Get the Linux version. Just take the defaults. Just run that guy. Okay, yeah, then we're going to go to options. We're not using protocol 1, so we can get rid of that. Found our 4 arms here, so that's good. We're going to use only 1,000,000 BPS, and we can change our port range to be 0 to 10. Press OK, and now scan. Complete. And now what we see is every motor in the robot. You can figure out which one's which. They have an LED. Power on the LED light here for, say, this motor. In fact, you know what? Just because it's going to look a lot cooler, I'm just going to turn all the LEDs on. And here's what the robot looks like with all the LEDs turned on. Pretty easy to see. Okay, so now we just need to map that arm. So that was the left master arm. As we can see, the left master arm is on TTY USB 0. So we need to run this command to get the serial number. So this is the serial number for USB 0. And then we're gonna open up the udev rules. Let's just do that in a different window. And then we're gonna copy this line. It's going to be the same, except instead of using this vendor ID, we're going to use the serial ID. Serial. I'm going to change that to be the serial number. And then we're going to change the symlink to be master left. Like that. Product ID, we don't need this, so let's eliminate that. Okay. So now we just need to repeat that for each arm in the system. Okay, so our next job is to set the maximum current for the gripper motors, stop them overloading. And so we're going to do this in the Dynamixel wizard. The follower arms are the ones with just the 2 XM430W350 motors. And so number 9. And so if you just toggle the LED on for this guy and then go check the robot. And on the robot, you'll see the LED light right here. Okay, now that we've found the servo, we just got to set the current limit to 300 and save that. Okay, so next we want to determine which video camera is which. So to do that, we're just going to type ffplay/dev EO0, and that will pop the webcam, and we can see that that guy is the left puppet. So then we'll try video 1, and that fails. Okay, so let's just go to video 2. And video 2 is front, the front cam. Video 3 is a fail. Video 4 is the top cam. Video 5 is a fail. Video 6 is the right puppet robot. So now that we've got the cams identified, we're just going to check each of those to get the serial numbers. So let's get the serial number for video 0. And there it is. And now we just want to add this to the udev rules. So we just take that. I'll create a new. And we'll just paste in the line, like so. And then we're going to put the serial, substitute the serial number. Okay, and 0 was the left-right wrist. So we'll just change this to left on my own wrist. And we'll just, while I'm here, copy that. And then we'll just complete that for the rest of the video cameras. Okay, so here it is complete. So we have the left, the right wrist, the front cam is cam low, and the overhead cam is cam high. So we just save that file, reload the udev rules. We'll wait for our keyboard to come back online. It may take a little while. There we go. Dev slash cam star. And there we go. We have cam high, left wrist, low, and right wrist. Now we want to create a new workspace for the project code. So to do that, we're just going to make a directory and we'll call it Aloha Workspace, and then we'll just cat and make. Okay, now it's happy. So now we're going to git clone this workspace. That'll be fine. And now we'll just cat can make. See what happens. Okay, that's built. Now we're just going to source. Okay, and then check the packages. Okay, and now Aloha is installed. So let's just try to launch the forearms teleop script. So now we need to get our video drivers installed so we can install PyTorch. I've got 2080 Supers on Linux, 64-bit. Yeah, we'll just grab those. I like to download the drivers off the website. I've had better luck doing it this way than with the package drivers that come with Ubuntu. So just get in there. Run the driver. Okay, let's try this. Okay, we're going to run the driver as root. Alright, we're about to run into a problem with the Novu drivers, and the driver installer is going to offer to resolve that for us. So we're going to let it try to do that and reboot. Okay, now we've rebooted and we're going to try to run the drivers again. And hopefully this will clear out the Novu drivers. Great, yeah, it looks like Novu drivers are cleared and the kernel module is being built. Don't want the 32-bit compatibility libs. Nope, X, no, don't need that. Okay, complete, awesome. All right, let's reboot and check it out, see if it's worked. Okay, let's run Nvidia SMI after rebooting, and great, we can see my cards are installed and visible. Okay, job done. Okay, so next we need to install miniconda for Linux. So we'll just download the 64-bit Linux version and go to the installation instructions for Linux. And then we just need to run the installer with bash. So that's what we do next. The name was a little different to what it said in the instructions. Then we agree to the legalese. There's quite a lot of it. Take the default install location. And then let's just initialize it to start out. That's going to, by default, start our terminal with the base install, which we don't want. So we're going to deactivate that using this command. And now you see that we have conda installed. So next we need to create the conda environment. So it's going to be a Python 3.8 environment. Okay, then we're going to activate that environment and install the packages. The packages are all installed using pip. So we'll just install them all in one go. Interestingly, it's going to pick up Torch 2. I'm not sure if Torch 2 is going to be a problem, so I guess we'll find that out in the future. The rest of the packages install without any problems since this is a clean environment. And then we just hit enter on the last one and we're done. Environment configured. Okay, so let's check that the cameras are reporting correctly. Ros launch Aloha 4 arms teleop. So we're just going to launch the 4 arms teleop script here. There we go, up and running. And then we're just going to start rviz. And to check the arms, I'm just going to add by topic. And we should see the different topics for the cameras here. And let's just take the cam high. Let's call it cam high and add it. And you can see that cam high is connected and reporting. And we'll just repeat this for each camera. Don't worry about the sizes. What's happening is this image is just being resized. And so you can play around with this if you like and get it laid out how you want. But as far as a cam test goes, we can see that all 4 cameras are reporting to Ros correctly. If you want to avoid having to add the cameras every time, so go to save config as, navigate to your home directory. Let's create the config file. Let's call it Aloha. Save it. We can just quit. And if we want to reload it, and if we want to reload the rviz, we can just go rviz minus the Aloha rviz, load it up, and you'll see your cameras are restored. Now let's align the cameras correctly. So to do that, we're going to pull up the reference images. So this is the reference image for the top camera. So we want to make this look as similar as possible to this. Okay, so I'm just going to use the white tape as a guideline. There we go. Now let's align the front camera. So that's going to look like this guy. Pretty simple, and there we go. So that's done. Okay, so that's the last step in the entire setup process of the robot. So now we've reviewed the paper, we've ordered all the parts, we've built the robot, we finally have all the software configured, and we're ready to start working with the robot. So in the next video, we're going to be starting up the robot for the first time. So I'll see you in the future.